Hello guys, welcome back to this very important video that we'll take a look at. We'll take a look at the internet and one very important component that makes it easy for us to use the internet, which is called the DNS service. My name is Kawar and I'll be going through and talking about these topics in this particular video. What are the main topics that will be discussed? We'll start by taking a look at the internet as a whole. We discussed it a bit in the previous video. We'll go into a little bit more detail about it in this particular video. We'll take a look at the basic services and protocols that work on the internet that make it usable for us. We'll take a look at DNS and the DNS communication process. So first of all, let's take a look at the internet. What is the internet? One of the things that we discussed about the internet was this global network that allows us to connect different company networks to each other, making resources and information available to the end user. Now, the way it's done is by connecting our networks, the business networks, the government networks, the school or college networks, into one big network, which is connected through this type of a company whose responsibility, the main responsibility, is to connect these different networks to each other. This type of company is known as the ISP, or the Internet Service Provider. Let me open up my magic pen over here. So the type of company that makes the internet possible is this genre of companies known as the Internet Service Providers, which we commonly refer to as the ISP. All right, so everybody connects their networks to their ISP network. The ISP networks are connected to each other in different countries, allowing these different company or different networks to connect to each other. Another name for the internet is a network of networks, because it allows us to connect these different networks for different companies to each other. Now, because these are different companies that are talking to each other, they need to be communicating to each other using a protocol that is known to everyone, a language that is spoken by everyone. And that protocol, that language that allows different networks from different companies to talk to each other, is known as the Internet Protocol, or the IP protocol. So the entire internet is communicating to each other to provide basic connectivity from one device to the other device based on this carrier protocol called the IP protocol. Now, I'm communicating on the internet. I want to send a request to a particular server. If I want to send a request to a particular server, just like when you send a letter to a friend, it needs to have an address assigned to it. This address has to be a unique address around the world, because if it's a duplicate address, the mailman would not know where to deliver the mail to. So it has to be a unique address. Similarly, on the internet, for me to be able to communicate to a server, each server needs to have a unique identifier that identifies that device, that server, uniquely around the world. And that address, in terms of the internet, is this address known as the IP address. This IP address has to be a unique address so that when I'm communicating to a specific server, it has a unique address not just within this service provider, but in the entire world. So when I connect and make a communication request to google.com, it goes to the google.com server, not to somebody else. Now, the address that you talk about as the connectivity, the unique address on the internet, is an address that is in the format of 4 numbers. So the way an IP address, the internet address, looks like is this: decimal number separated with a dot, another decimal number separated with a dot, another decimal number. So you have 4 decimal numbers, which is your digit, normal digit, 0 through 9, separated with dots. So this is an address which is known as the IP address. Every device on the internet will have an address assigned to it, which is a unique address called the IP address. And the format is like that. Just to give you an example of a typical IP address, I have put that on your slide over here. 200.1.1.5 is an example of an IP address that is a unique address assigned to a device on the internet. No other device would have the same address as your device or your server's IP address. Now, how do I make sure that this address is a unique address all around the world? There has to be some type of structure so that this address becomes a unique address around the world. And that structure is this. The address, all the addresses on the internet are controlled by a central authority called the Internet Address Numbers Authority, IANA. All the addresses are given out by this central authority that gives out addresses not just in a specific country, but all around the world. Now, what they do is they don't assign the addresses generally directly to the end user or a company. They generally assign this address to the service providers. And when IANA is assigning an IP address or an IP address range to the service provider, it makes sure the address that is assigning to ISP1 is unique to that ISP. So the addresses that will be assigned to two different ISPs will be unique. There will never be a conflict between the two. IANA makes sure that the addresses that it assigns to the different ISPs are unique addresses that are assigned to them. Now, once the ISPs get it, ISPs then in turn are responsible for assigning those addresses to customers. These customers could be entire companies, company A, company B. So ISP is responsible for making sure company A's addresses are different than company B's addresses, and all the different individual users that are connecting to the service provider. So all these addresses are going to be unique addresses, and it is the responsibility of the ISP to make sure the addresses assigned by the ISP to the end users are unique addresses. And that's how it is made sure, it is ensured that every address on the internet is a unique address identifying every device uniquely on this global network of networks. All right, hopefully that is clear to you guys now. Now the next thing we want to take a look at is, although the internet connects these networks to each other, what are the basic services, the most common, most popular services that are used on the internet? Now, one of the basic services that everybody knows about is a service by the name of the web service. The web service is the one that allows your browser to make a connection into a web page that has or hosts information about a certain topic. A company that is selling a product, it will put information about the product and how to buy the product on its website. A website is basically going to be a collection of different pages that basically are selling or giving information about a particular product that the company needs to sell. Now, in order to make this connection, you have three entities. The entity that makes the connection, that is known as the client. The client for this is called the browser. Whether using Chrome as a browser, you're using Microsoft Internet Explorer, Microsoft Edge, Mozilla has Firefox, all the different browsers that you have. It doesn't matter what browser you use, because at the end of the day, the connection will be made based on IP to connect the two different devices to each other. But at the same time, the browser needs to access a particular service. So the browser, when it makes a request, it uses a protocol that runs on top of IP to allow the browser, the client, to communicate to the server. The server for the browser is generally going to be a web server. And the protocol that rides on top of IP is going to provide the connectivity. The actual communication that happens on top of IP is done by a protocol known as the Hypertext Transfer Protocol, HTTP. This is the most common protocol that is used on the internet to access different web servers, web pages, information on the internet. All right, that's the first one. The second service that is also commonly used on the internet is this service known as the email service. What is that used for? Email services are used to send and receive emails from your friends, for a company, for different jobs that you might have applied to. Rather than sending letters, taking time for that email or that letter coming back, email services make it almost instantaneous to get the information across to your client, to maybe you might want to send an application for your college. Everything is done through emails today. Now, in order to do that, again, you need to have a client. Now, in this case, the client over here is going to be something like an Outlook mail client connecting into a mail server, an email server. An example of that is the Exchange server from Microsoft. The connectivity, again, is going to be provided by IP to connect the device to device, but the communication that will take place for sending and receiving mail is another protocol that rides on top of IP known as the SMTP protocol. As we go through the course, these terms, these protocols will make more sense. I'm just introducing it, trying to relate it to something that you use on a regular basis. So when you're sending an email, the protocol in the background that is being used to transfer that email or for you to receive the email is this protocol called the Simple Mail Transfer Protocol, or the SMTP protocol. All right, again, another common service that's used on the internet. The third service that I'm going to talk about over here, which is called the name service, is one of the most essential services to make everything else work. Now, let's take a look at normal communications that we as humans do. Let's say I want to go to a city. Let's say I'm in the US and I want to go to Los Angeles. Los Angeles has a zip code assigned to it for the purpose of mails, location identifier. The zip code that you have is a number. For example, the zip code for Los Angeles is in the 9000 series. Now, if I want to go to Los Angeles, I'm not going to tell my friend, hey, listen, I'm going to 9001 or 90001. I'm going to tell the user that I'm going to Los Angeles. So we as humans are more used to using or referring to to locations by using names. We're not too comfortable using numbers to identify things or locations or people. People is an example. If I want to communicate to another person, I'm not going to point to him using his, let's say, a social security number. All right, I'm going to point to him by using or refer to him by using his name. Similarly, on the internet, although the underlying communication mechanism, the way I locate a particular device uniquely, is that number known as the IP address. But we as humans are not too comfortable using the address. So what happens is there's another service that is used in which in addition to assigning a server an IP address, I also assign the server a name. The name is broken down into two parts. One is the company name, which in terms of the internet is known as the domain name, which refers to the name of the company. For example, google.com is the name of Google, the domain name for Google. But on Google, my web server will be identified by using the host name, which is called www, or the SMTP server would be called smtp.google.com. This becomes what is known as the fully qualified or the full name for that server, which is the host name, the device name, along with its company name. Like the first name and last name, well, the last name is the company name. Now, this server will also be assigned an IP address, let's say 150.1.1.1. When I sit on my browser trying to go to google.com, I'm not going to type in 150.1.1.1. In reality, actually, one of the common addresses that Google uses is this address called 8.8.8.8. This is Google's IP address. So I'm not going to point to 8.8.8.8. Instead, I'm going to say www.google.com. Although as a human I'm more used to the name, the internet does not work based on the names. It works based on IP addresses. So there needs to be some type of server that would know who www.google.com is. So when the request is made by the client, The client first needs to figure out what is the IP address of the destination device that I want to go to, not the name. So he'll go to this server and find out, hey, listen, who is google.com? And the response will come back and saying google.com is 8.8.8.8. Based on that, the client browser will make a request to 8888. It doesn't really care about google.com when it's actually sending the packet. It cares about the IP address of google.com. And this server is known as the name server that resolves the name to its corresponding IP address. The protocol that is used to do this resolution for you is this protocol called DNS. So the purpose of DNS is to do the name resolution where it resolves the domain name, the fully qualified domain name, which is the hostname.domain name, to its corresponding IP address, so the communication can be done based on IP. So that is a very important service in our internet communications. Now, the next thing I want to talk about is show you a picture of what the internet looks like. This is a typical internet connection in which I'm showing you that the ISPs are connected to each other to form the internet. The ISPs also on the other side are connecting to either home users, either using the home user can be completely using Wi-Fi, or the home users can be using a combination of Wi-Fi as well as wired, which I showed you in the previous video. And then on one side, it is also connecting to different companies. A company router over here. Again, the devices that connect the different networks together, which we talked about in the previous video, is this device known as the router. So the ISP router connects to the company router, which in turn has two local networks over here, which has PCs on one side, another network which uses switch to connect the different devices on the same network together, has the web server, the email server, the DNS server. The other company router is also connected to his ISP, allowing the PCs and its servers available on this public network known as the internet. So basically the internet is a connection of all these different ISP routers to each other. ISP routers in turn connect to either the company routers or the individual homes to allow this connection of all the different networks around the world to each other. Now, once this is done, again, the communication, as I said, is done based on these individual unique IP addresses. So the routers over here would know where a particular IP address belongs to. So when a request comes in for a particular IP address, it not only knows that this address is reachable, it will know the next router that can get it to that IP address. For example, if I have an address assigned to this company as 200.1.1.5, this router would advertise, hey, listen, if you want to get to 200.1.1.5, it will tell the next router, send it to me for 200.1.1.5. Send a request that is destined to 200.1.1.5 to me. This ISP will tell the other router, the other ISP, listen, if you want to go to 200.1.1.1, send it to me, I know where it's at. Similarly, this router would tell this router, if you want to get to 200, send it to me, I'll get it to 200.1.1.1. And that's what happens over here. Once a request comes into this ISP, says, oh, the next hop for this request is this ISP, sends it to this one. He knows to get to 200.1.1.5, it needs to send it to the following ISP. He sends it to this ISP, and he knows it's connected over here. That's how the communication works over the internet. But the thing is, although the internet works based on the IP addresses, as I told you, we're not used to using IP addresses in our communications. So we're going to be using, rather than using IP addresses, I'm going to be using names. And that's the process that I want to talk about in the next slide over here, which is my DNS server. When we want to access a server like on the internet like Facebook or Google, we will do it based on the name, not the IP address. Again, I also gave you that example early on that I'm going to refer to those based on what? The cities based on the name of the city, not its postal or zip code, so that when we communicate to our friends, they know what I'm talking about, because we're used to names rather than numbers. Now, again, the DNS server's responsibility is to make sure that this communication happens with transparency to the end user, where the end user types in the name, the device, your PC will go to its DNS server, try to resolve that host name to its corresponding IP address. The protocol that is used for this communication is this protocol called DNS. All right. Now, how does it work in terms of DNS? Let's take a look at that. Let's discuss that a bit in detail because I want you guys to know that inside out. I want to demystify the concept of how when you sit on your home and you make a connection to the internet, how does that work? The way it works, first of all, is you want to connect up your company to the internet. What you do is you go to your ISP and say, hey, listen, get me a domain name. And not only do I need a domain name, I also want you to get me a IP address assigned for that domain name. I want to have maybe 3 servers or 4 servers. Give me these addresses for my service. So let's say my company name is kbschool.online. Let's say I get a range of addresses assigned to me. Let's say 199.111 through 199.1110. So I have 10 addresses assigned to me. So once I get that, this is my domain name and this is my range of addresses. On my network, on my router, I am going to connect my DNS server, in which I'm going to assign the DNS server one of those IP addresses in this range. Let's say 199.117, and I'm going to assign one address to my web server, 199.118. Now, besides giving the address to my web server as 199.118, I am going to assign this web server a name. I'm going to call this web server www, and because it belongs to kbschool.online, the full name becomes www.kbschool.online. All right? So that's the full name for this particular server. Once I do that on my DNS server, I'm going to create that entry saying if somebody wants to reach www.kbschool.online, the IP address for that KB School web server is 199.118. So this information is on my DNS server, but the ISP over here, the other ISP over here does not know that, does not know my DNS server address. So he does not know kbschool.online's web DNS server is 199.117, which has the resolution for the web server. So in addition to this, what I need to do is I need to register the IP address of my DNS server with what are known as the root DNS servers. On the root DNS server, I'm not going to put my www.kbschool.online. Instead, I'm going to say the DNS server for kbschool.online is 199.1.1.7. So the way it works, when the client over here makes a request and he wants to go to www.kbschool.online, he'll make the request. In the background, the client will be configured with his DNS server, which is generally going to be a client uses the ISP's DNS server for doing the name resolution. It says if I don't know a name, I'm going to go to the DNS server for the ISP, and he will be given the IP address of that server. Let's say 150.5.1.11. That would be the DNS server down here. This is the ISP's DNS server. When this request from the client, which is made for www.kbschool.com, comes to the ISP's DNS server, he does not know where www.kbschool.online is. But what he knows is the IP address of the root DNS server. So it sends a request over here saying, hey, listen, I don't know where www.kbschool.online is, but do you happen to know the DNS server for this domain? It says, yeah, I know. I don't know who www.kbschool.online is, but I know where you can get that information. You can get that information from 199.117. The ISP thanks the root DNS server and makes a request. Now to whom? To the DNS server for kbschool.online, saying, you know what, one of my clients wants to communicate to www.kbschool.online. Do you happen to know his address? He says, yes, absolutely, I know the address. The address for www.kbschool.online is 199.1.1.8. So the ISP's DNS server gets the information. He will relay that or forward that information to the client. The client says, thank you very much. I'll make a request with the destination IP address of 199.1.1.8. This is all unknown to the end user. He thinks he's communicating to www.kbschool.online. In reality, in the background, it is actually communicating to the IP address for the kbschool.online website. And all this is done transparently. All of it is done in a matter of seconds. So all the thing that I explained to you guys over here is the job of maybe 3 seconds or 4 seconds or 2 seconds. That's the time it takes for the website to come up. So I've done that for you guys over here. I've shown you a diagram over here. Let's take a look at this. In this, what I just explained to you guys, I have my home devices. Their DNS server is going to be the ISP's DNS server, which is 150.5.1.11. So on their home computer, it would say the DNS server that you need to go to resolve any address is 150.5.1.11. So when a request comes in for www.website, it will go to 150.5.1.11. When it reaches the ISP's DNS server, if it does not know the address, it will contact the root DNS server. In my case, I'm showing you 2 root DNS servers for backup, option 1 and option 2. So it sends a request to the root DNS server asking what? Do you happen to know the DNS server for, in my case, I'm using qrb.com over here. It says, yeah, I know it. It's 199.1.1.6. Says, thank you very much. Gets the resolution for who the DNS server for qrb.com is. Based on that, it will then send a request to 199.1.1.6 asking it, do you know who www.qrb.com is? The response will come back saying the IP address for www, the web server for qrb.com, is 199.1.1.7. The ISP's DNS server will get that information, relay that information to the client. The client then makes a request to 199.1.1.7 based on the resolution that the DNS server did. And that is what I'm showing you guys over here in this particular slide, the steps that are taken. So for example, here, to recap this, step 1, user types in www.qrb.com, trying to go to the website for qrb.com. Step 2, the user's PC will send a DNS resolution request to its DNS server, generally the ISP's DNS server, which in my case over here, based on this example, is 150.5.1.11, to find the IP address of www.qrb.com. Step 3, the ISP's DNS server will then try to find out who the DNS server for qrb.com is. So it's going to contact its root DNS server, which in our case was 5555, sends a request for the DNS server, that is the name resolver for qrb.com. The root DNS server will respond back with 199.1.1.6. That is the DNS server for qrb.com. This is the guy that will actually have the host information. So now that the ISP's DNS server has that information, it will then make a request to the ISP's DNS from the ISP's DNS server to qrb's DNS server, asking it what is the IP address for www.qrb.com. Response will come back saying, if you want to reach this address, this is the IP address for it. The DNS server gets it, forwards that request to the user's PC, and the user makes a request to this destination address. Now, as I said, the whole procedure over here is done within seconds. So a lot of moving back and forth, but at the end of the day, you will get that request, and it's done all behind the scenes. So just to demystify the fact when you sit on a device, how is that request going? Where is it going? How is the communication working over there? All right. So that's what the takeaway that I want you guys to have from this particular video is how DNS works, how does DNS make it easy, what are the different common services on the internet, what is the internet. All right, let's take a look at some key concepts that I covered in this particular video. Dash is also known as the network of networks. That would be your internet. The main communication protocol on the internet is the IP protocol. The three most common services running on the internet: the web service, you can even say www service, the mail service or email service, which is also based on the SMTP protocol, and the name resolution service, which is your DNS. What service protocols is responsible for sending and receiving emails? That is the SMTP protocol. What service protocol is responsible for allowing end users referring to servers on the internet using names? That would be your DNS server. All right, so that is it for this particular video. Again, one step at a time. Just make sure you focus on the different concepts that have been covered in this particular video. We will go through, there's over 100 videos in this course that you will go and learn about small topics, and at the end of the day, you will have conquered this giant. Thanks for viewing, and I'll see you in the next video.